An operation is a rule that assigns each ordered pair of elements in a set to exactly one element within that set. Consider the set including A, B, and C, with the operation star represented by an asterisk symbol. Any element operating on any other element in the set, including itself, would have to equal another element within that same set. In this way, an operation maps a set to itself. There are a few criteria we can use to determine if a rule is an operation. First, every possible ordered pair of elements in the set must have a defined output under the operation. Second, that output must be unique, meaning that there cannot be two possible outcomes of A operating on B. Finally, the output of A operating on B must be within the original set. Let's take a look at an example. Consider the set A containing the two elements -1 and 1. We can use a table to evaluate the outcomes of a particular rule. In each column, we'll list the value of A, the value of B, and the values of A operating on B and B operating on A respectively. In the example we'll cover here, A star B and B star A will be equal, but please note that this is not a requirement for operations. Let's first consider simple addition. Here we have -1 plus -1 equals -2, -1 plus 1 equals 0, 1 plus -1 equals 0, and 1 plus 1 equals 2. Let's consider each of our rules for an operation. First, it's clear that A plus B is defined for every ordered pair in our set, and there is only one value of A plus B for each ordered pair, so rules 1 and 2 are satisfied. But notice that our possible outputs are -2, 0, and 2. Because at least one of these outputs is not in our original set, we can determine that addition is not an operation on the set A. Now let's take a look at multiplication, again utilizing our table. Here we have -1 times -1 equals 1, -1 times 1 equals -1, 1 times -1 equals -1, and 1 times 1 equals 1. Again, it's clear that rules 1 and 2 are met, but this time the possible outputs are -1 or 1, both contained within our original set A. From this we can conclude that all conditions are met and multiplication is in fact an operation on set A. While we've covered the three requirements of an operation, it can be helpful to define some other properties that operations might have. Keep in mind that it is not guaranteed that any specific operation has any of these properties. If the output of A operating on B equals the output of B operating on A for every possible ordered pair in the set, then the operation is said to be commutative. If while keeping the sequence of operands the same, the order in which the operations are performed does not change the result of the expression, then the operator is said to be associative. If an element E exists in a set such that any element in that set operating on E or being operated on by E equals that same element, then E is called the neutral or the identity element. If an element X exists such that A operating on X and X operating on A both equal the identity element, then X is called the inverse of A and can be denoted by an A with the superscript of -1. Again, none of these extra properties are absolutely required for any operation, but they are very important in the study of groups. So, what is a group? We'll find out in the next video.